Hello everyone, and not today, this video I'm going to do a demonstration on one N chapter problem. Is in chapter 3, in problem 555. And why I want to do the demonstration of this problem? Because I think his answer is not 100% reasonable. So I give you my point of view. So the problem is like this. It give you a position vector, okay, and it's two dimensional. It's two dimensional position vector, and the component of x component and y component is a function of time, and CD are positive constants. He asks when is the particle moving in x direction and when is the particle moving in y direction. Okay, from its answer, his how he get the answer. So let's first follow the follow the manual solution manual. It says that if you a particle moving in x direction, so that means your y component velocity y component is 0. Okay, that's moving in x direction. Okay, so and if you're moving in x direction, if you're moving in y direction, that means your x component velocity is 0. Okay, so it give you the problem give a position vector, and how to get the velocity vector from the position vector? You just do the derivative, okay, as a function of time, and we did this before. So I don't want to write the detail of it. So check it by yourself. Okay, plus J 4ct minus 3 dt square. Okay, this is your velocity factor. Okay, so with this moving x direction, that means your velocity of y component is 0. So velocity y component, yeah. I show you. Yeah, maybe here's okay, here's J. Okay, the velocity of y component is 0. Okay, so 4ct minus 3dt squared is equal to 0. So it will become t 4c minus 3dt equal to 0. So the solution is t is equal to 0 or let's say 4c over 3d. Okay, so we use the same concept. When is the particle moving in right direction? Moving in right direction, the manual say this means your velocity x component of velocity is 0. So x component velocity is 0, so 2ct minus 3dt squared is 0. Okay, so t 2c minus 3dt. Did I do it right? I do it right. Okay, so the answer is t equal to 0 or 2c over 3d. Let me check. Did I write something wrong? Ct squared 2 minus 2dt 3 minus 2ct 3 6dt squared. This is 3dt squared. Sorry, this is 6. Okay, 6 here. I should do the erasure. This is 6. Sorry. This is 6 dt squared. So this is should be here it's 6. This is 6. This is 6. Sorry, 6. So this will become c over 3d. C over 3d. Okay, so that's the answer. And for time equal to 0, that's not the answer we want, because time equals 0, that means this particle doesn't do any motion. So of course it's on x direction. It's moving on x direction on y direction because it's at the original point. So this is not solution we want. So the answer tell you that at t equal to 4c over 3d, it's moving in x direction, and when t equal to c over 3d is moving in y direction. But that's not pretty accurate. This only means at this time the particle is on x-axis. So this is So this is, I think this problem is not ask the right question. So the answer just tell you the particle at the x axis. Okay, so and this one is the particle at y axis. Particle at y axis. But that doesn't mean this particle is moving in x or y direction. So these two answers just indicate that the particle at the x-axis or one on y-axis. It doesn't indicate anything about its moving x direction, y direction. Yeah, why? Okay, let's do a further analysis. We just calculate acceleration vector. Okay, let's do the acceleration vector. So acceleration vector, how do we apply acceleration vector? Just do a derivative of a velocity vector with respect to time. You will get the acceleration vector. So acceleration vector. Okay, acceleration do a derivative again with respect to t, with respect to 2c minus 12 dt I plus 4c minus 6 dt j. Okay, this is the acceleration vector. So let's put the time we obtain. So when the t equal to 4c over 3d, when t equal to 4c over 3d, the acceleration vector is 2c minus 12d and 4c divided by 3d I, okay, plus 4c minus 6d, 4c divided by 3d, and j. What this tell you? At this moment, okay, let's do a little calculation. This will become 4, this will become 4, so this will become minus 14ci. Okay, this will become dd cancel is 2ac, so it's plus minus, sorry, so it's minus 4c plus minus 4c j. Did I do the calculation right? Let me check. Is this the right answer? Let me check. It's a bit different. It sounds like a bit different. Okay. A is minus 2. Oh, no. Minus AC. Did I do the calculation correct? 4c minus 6bt. 4c over 3d. 4c over 3d. 4c over 3d is 2. Yes, minus 4. Minus 4. Ah, so that means I write it wrong here. This is correct, I think. This is correct. Minus minus 4c. Okay, this is the screen is correct. Okay, this tell you at this time, yeah, the particle is on the x-axis. That's true, but its motion is not. It's not on the along the x direction, because when we draw this picture, it will look like this. It's about here. It's 14. It's 4. So its acceleration vector is in this direction. So at this time, the particle is on at the x-axis, but it does not move along x-axis because its direction is not on the x-axis. Okay, so that's why I think this problem is not asking the correct question. So we check the other time. You say at this time the particle is on y-axis. So let's check. It's really moving on y-axis minus 2d. 3D 4I plus 4C minus 6D C over 3D J. So it's cancel out. This will become 2. This cancel out. It becomes 4. So it will become minus 2C plus 2C. It's IJ. Okay. So that means the calculation result means at this time, yeah, it's at the y-axis. It's at the y-axis, but its direction is not along the y-axis. Its direction is, yeah, let me draw a simple picture. It's 2, 2. Okay, it's 2, 2, minus 2, 2. So its direction is here. Its acceleration direction is here. So it's at this time it's at the y-axis, but it's moving in this direction, but it's not on y-axis. So that's why I think the answer is not 100% correct, and I think his problem is not asking the right question. Okay, so this is my view to this 3.55. So I hope you can understand this problem, and see you in next video. Okay, bye bye, bye bye, bye bye, bye bye, bye bye, bye bye.